Now this illustration deals with control and signaling cables. In accordance with 392.22a6 and Table 392.22a6, and we're performing the calculation according to this section in the table. Case 1 is to the left, and notice step 1, we are referencing 392.22a6. We have 18.3 square inch area for those conductors listed there. And when we do the math, that's a 6.3 square inch area. Now we have 35 at 15.15 square inch area, and we do the math, it's 5.25. So the total of step 1 is 11.55 square inch area. Now, applying the multiplier of 392.22a6, we would take 11.56 square inch area, do the math of 50%, we come up with 23.1 square inch area. Step 3, we apply the depth of the tray. And of course, 392.22a6, we reference Table 392.22a column 2, and we would take the 23.1 square inch and do the math with the 4 inch, and we come up with 5.775. Now the solution, we would select a cable tray with a 6 inch width, and that is what would be required. And then the note says, in the case of a solid bottom tray, the multiplier is 40% that we would use instead of 50%. And of course, when you did your math, you would come up with 7.2, in which a 12-inch cable tray would be required, Table 392.22.6. So this is using cable trays in case 1 for signaling type circuits that we would be using there. Now we're moving into step 2, and I believe these are control type circuits. Now notice here that we're using a solid bottom tray. So step 1, we have 16 times 0.170 would equal to 2.72. And then selecting the cable tray, we are referred from 392.22a2 to Table 392.22a, and the 2.72 square inch area would require a 6 inch tray. So in the solution and answer, the size cable tray required is 6 inches per Table 392.22a. Now this is showing control and signaling cables, and then of course we get these known values from the previous illustration showing the conductors in the cable tray for case 1, and case 2 is you see the calculations performed for case 1 and case 2 in this illustration.